Good morning. Happy Wednesday. It's Wednesday today. Just a little before 5 a.m. here in Arizona. Beautiful Arizona. Smab, good morning. Or good afternoon for you, I suppose. Let's get this chat box over here. No worries, no worries. You're under no obligation to stay. I'm glad you could pop in just for a moment. We're happy to have you. Really happy to have you. G, good to see you as well. I hope you got some sleep. I know you were up late last night or early this morning, depending on how you look at it. But it's great to see you both this morning. We are, oh man, getting. I had the G. You were trying to tell me about my error. Um, yeah, you were trying to tell me about my error, my off by one error in my solution. Oh man, it was bad. But we got it figured out. I ended up implementing a circular linked list. Um, oh, I ended up implementing a circular linked list that shifted things one at a time, and that's how I ended up just figuring out what my bug was. Oh, it was so frustrating. But we got it. We're I'm getting worn down. I'm getting worn down. Um, on these puzzles. I'm hoping today's not too bad. But we're gonna take a look. Yeah, Smab, I saw yours. I ugh, I wish I had done something intelligent. But, there's always next year. We get another puzzle like this next year, maybe. Alright, let's get a workspace set up here for day 21. So I kill myself. It's so frustrating sometimes because I yesterday my very first thought was let's do a circular linked list, and then I immediately went, well, there's going to be some inefficiencies in that because you got to keep moving around in it. And so then I said, oh well, let me try and do this smart thing with a semicircular array where I keep track of indices, and then my brain got all in the rabbit hole. It turns out this actually works. The I got to put list -1 here. This was the, I had an off by one error. Oh, anyway, we're gonna pretend yesterday didn't happen. Let's get a new project set up here. Use the circular list type. Yeah, I mean the you don't have to have a fully working circular linked list for yesterday's. The sort of worked out. Or not too hard to implement the pieces that you do need. You need like an add and a remove, or an insert at and a remove. Let's get this up. I need to add in here reference. Yeah, this is the first time it's just the rules for wrapping around that got me. Oh man, the rules for wrapping around killed me yesterday and sent me down a rabbit hole. All right, let's take a look at what today's. I'm nervous because the last monkey problem hurt my brain. What's going on here? Oh, this is Unity. Close that. Yeah, the last monkey. Oh, come on. The last monkey problem. So we'll see. Well, we'll see here if we get have a similar monkey problem. Come on, let me generate that. Okay. The monkeys are back. You're worried they're going to try to steal your stuff again, but it seems like they're just holding their ground and making various monkey noises at you. Eventually, one of the elephants realizes you don't speak monkey and comes over to interpret it. So apparently we speak elephant, though. As it turns out, they overheard you talking about trying to find the grove. They can show you a shortcut if you answer their riddle. Each monkey is given a job. Either yell a specific number or yell the result of a math operation. I'm really curious if the elves were turned into elephants. Because why else would they have like the distress signal? Why aren't the elves responding? I'm slightly convinced. I've convinced myself. I think it'd be such a cool twist. Maybe not twist if the elves got turned into elephants. All the number yelling monkeys know their number from the start. However, the math operation monkeys need to wait for 2 other monkeys to yell a number. Those 2 other monkeys might also be waiting on other monkeys. Your job is to work out the number the monkey named Root will yell before the monkeys figure it out themselves. For example, we got input here. This looks like an abstract syntax tree problem where we have variables, arithmetic, binary operators, and integers or nums. Each line contains the name of a monkey, a colon, and then the job of that monkey. A lone number means the monkey's job is simply to yell that number. A job like means the monkey waits for the monkey AAA and BBB to yell each of their numbers. The monkey then yells the sum of those 2 numbers, etc. Subtraction, multiplication, division. So in the above example, monkey DRZM has to wait for monkeys HMDT and Zik to yell their numbers. Fortunately, both Humt and Zook have jobs that involve simply yelling a single number. So they do this immediately. 32 and 2, monkey DRZM can yell its number by finding 32 minus 2. Then monkey, this process consists on the Root yells the number 152. However, your actual situation involves considerably more monkeys. All right, yeah, so woohoo! I'm gonna build up abstract syntax tree, I suppose. Yeah, it's just part 1. Let's try and build up. So we're gonna build up a hash map of expressions. The zombie killer whale, thank you for following. I hope you're here learning something, or at least laughing at me, getting something out of this. We're gonna try and solve this though. I'm gonna try and build up. I'm pretty sure. So each time we see one of these, we're gonna add a node, and then we every node sort of knows it's like left and right or e-value. So we have like this idea of an expression, and every node has an expression, and the expression can reference other expressions. Then we're gonna write an evaluate function that sort of goes through and build and evals. And hopefully that will be good enough for part 2, but we'll see. We'll see here. So we have create an expr record public record expression. And the idea is we have an abstract record expression, an expression as an eval function, public abstract int eval. Should probably make this return a long, just because that's what the problems in these darn puzzles require. Quick question: I changed the way my video output is working. Is the font? Is this still? Can you read my screen? The text here, is it fuzzy? Yeah. So exactly. I'm gonna build up a hash map essentially from um, key, so monkey to expression, and then we recursively evaluate it. All right, cool. Not fuzzy. Good to hear. Yeah. So anyway, I modified my stuff a little bit. Cool. Thanks for the heads up there on the size being a little bit bigger. So we're gonna have an eval, public record. We got a val expression, int val, and public override int eval. Do I have to do an override here? Return val. What is that? Val names cannot be the same as okay. Well, then we'll have value. And I think I do need to put override here, right? No. Okay. If I wanted to subclass it, I would have to. And then we kind of have bin operators, public record. Bin op is going to have an expression left, an expression right, and a probably just do a char. Yeah. Char op. Gotcha, G. Yeah, that was sort of my I've seen this, and my initial thought is, all right, we're gonna do bin op, just to try and do a simple possible recursive abstract syntax tree as we can. Oh, okay. I can pump that up too. How is that? Did that? All right. Thanks. We're just trying to figure it out, figuring things out as we go. And then eval here. Oh, that's why it wasn't saying override was working. I was thinking you had to do override. Perfect. Yeah, so previously I had the rightmost part of my screen was getting cut off. So I've trimmed off my taskbar at the bottom. I don't think I want my taskbar visible on my recordings, and it's not really helpful to have it visible. So I trimmed it off, which makes it like slightly not the right size. And so I used to scale it up downward, and then the right side of my screen would get cut off. Anyway, so I told it to just stretch it, fit in there, because it's only missing like 40 pixels on the bottom. I didn't think it would be that bad. In this case, int eval. Right. In this case, we're gonna return op switch of. If we have plus, we're gonna left.eval plus right.eval. We have multiplication left.eval times right.eval minus left.eval minus right.eval. And is this all the way down? Yeah. Division. So my thought here, I mean, this should be fine. Otherwise, throw new exception cannot eval bin op ch. Okay. Oh, I called it op. Okay. And then Oh, and then I need a variable. I need a variable. That's right. So I need, because we have vals, we have bin ops, and then we have public record var string key. So this one, we have to give it like a lookup table. Yeah, it's a hash map. Not a hash map, dictionary. And maybe I just have like a big global dictionary. Think about what I want to do here. Yeah, so eval sort of has like a scope, so it might make sense to have this method take in a scope, but instead I'm gonna make, this is dumb, but I'm gonna make the dictionary take in an expression, a string to expression. What do I want to call this? Lookup. And then public override. Int eval goes to lookup of key dot eval. Yeah. Okay. So this is our basic evaluator, evaluating an abstract syntax tree. Now we got to parse in all of our expressions. So we're gonna put a parse here. Public static dictionary string to expressions. Parse string row. So we're gonna parse each one. Dictionary string expression. Lookup. Give it a new lookup, and then we need to sort of extract chunks out of our program. So we're gonna have like a parse expression. Yeah. Okay. I don't think this is too bad. Let me look at this code here. Do we have anything? Looks like we'll always have an expression, variable bin op. Yeah. So if I detect one of these, okay. So we're gonna do for each string row in rows, row dot split on colon. Want a couple of these just so I can have it in here. Split it. The left side, string tokens, is this, and our string key is tokens of 0.trim, and our string expression is tokens of 1.trim. Right. I'm gonna write another parse that parses an expression for me, so that I can just sort of do lookup key equals parse expr, and that will just sort of know what to do. Keep that simple. Public static expression parse expression string row, or this should be expr. So we are gonna say, we're gonna just try to parse. So if About to sneeze, I think. You ever feel the sneeze sort of building up and you're not quite sure if it's gonna happen? Oh, it might not. It passed. I scared it. We're gonna parse this expression int out value. We'll do this for now. Out int value. So if we're able to just parse it as an int, we'll return a new val value. Easy. Otherwise, oh, what did I do? Otherwise, we're going to get tokens from this one. So we can cheat a little bit. We don't have to have any sort of parser combinator because we know it's going to be 3 tokens. And then we can sort of do a match on the middle token. Tokens equals expression.split. And then we'll match on the, well, just for fun, left tokens 0, string right equals tokens 1, string, oh nope, string op, string right equals tokens of 2, just for simplicity. And we'll trim those just to be safe, though I don't think we need to. And then we will return, we'll match on our op. Let's go ahead and ban that user. All right. What's going on here? All right, so we got 4 cases again. We have oh, my brain just died. But I know these ones, so left and right, I can actually make these expressions off the bat because it's a new var. New var. And we'll pass in. This is just bad design on my part, actually. Thank you. Thank you. My eval should take in this thing here. Yeah. We'll call this lookup. Yeah. So rather than these having lookup, we'll add it into each one of these. And then we just sort of propagate it down. Okay. Oh. Okay. Let's propagate that on down, so that I can get my var in here, and then we just return. I don't even have to switch on this because I've designed it the other way. We're going to return bin op, new bin op, left, right, and then my operator happens to be that character. Okay. Magic, maybe. So let's see if we can parse this in, and then we want to call eval on root. I'm gonna be amazed if this happens to work on my first attempt here. String. Had so much not working on my first attempt that I gotta make an example.txt file that I no longer trust myself. I get our example in there. Get my input in there. All right. Example.txt, and then we, oh, my keyboard has stopped responding here. Let's try reloading. Yeah. Ooh, I didn't even think about a recursively defined thing. At that point, I would just be very sad. So we should be able to get back a dictionary of keys to expressions, vowels or bars, bears, expression.parse rows. Oh no. That what if it's recursive, then how do you'd have to do like I don't know. I think that'd be very mean. We're gonna try not vars root.eval console. Oh, and then I have to tell it vars console.writeLine results. Oh, I'm not in Python. That's interesting. I haven't written Python or JavaScript in many days, many weeks. I'm amazed that I wrapped it in single quotes there. Run project solution. 152. Okay. I'm feeling all right. Well, the negative number there makes me feel less confident. I'm gonna have to switch this to longs, aren't I? Boy. Yeah, I was gonna say my immediate thought at the very beginning was I should probably be using longs just because that seems to be the rule in advent of code. So let's update all of these to long. I should have just done that to begin with. Where'd my int.parse? This should be long. Long number, otherwise it'd be two. Otherwise you'd get it on the first try. Well, we'll see if we get it on the. So my thought is I shouldn't be like memoizing expression results, but we'll see. All right, there's a not negative number. All right, part 2, destroy me. That's so refreshing after yesterday. So refreshing after yesterday. Smab, thanks for hanging out. Have a beautiful day, my friend. We'll see you next time. Best of luck. All right, part 2. Part 2, due to some kind of monkey elephant human mistranslation, you seem to have misunderstood a few key details. Zombie killer whale, yeah. Yesterday, not yesterday. Oh my God. I went down the worst rabbit hole. The worst rabbit hole of Off by One. I rewrote it from scratch and still had the same error. And I was going, what the F? What the heck is going on? Um, it was rough. Mab, I look forward to it. I look forward to it. All right, first, you got the wrong job for the monkey named Root. Specifically, you got the wrong math operation. The correct operation for monkey root should be equal, which means that it still listens for two numbers from the same two monkeys as before, but now it checks that the two numbers match. Okay, so we need an equality binary operator. That's interesting. Second, you got the wrong monkey for the job starting with hummin. Hummin isn't a monkey. It's you, human. Oh. Actually, you got the job wrong too. You need to figure out what number you need to yell so the root equality check passes. That number appears, the number that appears after human in your input is now irrelevant. Okay. In the above example, the number you need to yell to pass root's equality test is 301. It's because root to get the same number, 150 from both of its monkeys. What number do you yell to pass root's equality test? The number you need to yell to pass root's equality test is 301. I don't quite understand what this is asking, so I'm gonna have to read it slower. I understand that root is now an equality check. All right, so we have like an equality operator. We want it to be true. If human, in the above example, I thought it was, I skipped this part. My brain didn't see this. I thought it was saying the number I need to yell is 301. Okay. Okay, so this is like, this is interesting. This is interesting. So, this is interesting. So I have a left and a right, and then I need to do like a linear, like, I can't remember the name of it is, but you have to like, I understand it now. So I have to do like a linear thing to solve for a variable. So I reduce it down. Let me see. I could probably do it by hand. I could reduce the left expression and the right expression such that all that is left is, humming. And then you just solve for humming. I could probably write a program to do it, but let me see if I can get it to print out my expression at the end. And then you have to solve that equation, which I'm not 100% sure I've ever written a program to do it, but I know that they exist. It'd be like a symbolic equation solver or something like that. I've done it in MATLAB. I've done it in MATLAB where you have like a 2D vector and you say, give me all the possible values. Okay, let us I've never written the code to do this. I know of this type of program. Wolfram Alpha does this. So I could probably just get it down to where all I have left is my humming expression. So it's like I need an expression that is like a partially evaluated expression. So like I have a new expression, partial expr. And so like humming is a partial expr. String symbol. There's also this idea of like, this reminds me a lot of, I did program synthesis when I was in grad school, and it reminds me of programming with holes. So you have a programming language and you can put this like a question mark in it and you ask, you say, can you generate a program that passes all of my unit tests by filling in this hole? So The problem becomes now when we evaluate something with a partial expression in it, it's like everything needs to account for the partial expression. Oh, I guess we only have the bin op, so the bin op's the only one that really has to account for it. All right, so we have a partial expression symbol. Expr. Ooh, and I no longer return a long. Like I want to return like a continuation. Get salad. I hope that, let me know if that's not how you pronounce it. Get salad. Come on in. Yeah, you're always welcome to hang out. Chat if you like. If you want to lurk away. But welcome aboard. We are working on part 2 of day 21 of the Advent of Code, which is pretty interesting. Yeah, so my expression no longer returns an eval. It's like it returns an expression now, right? So the idea is like we have a simplify. So what I'm going to do, rather than eval, I want to write a simplify. Yeah, don't spoil it for me. Part 1 was pretty straightforward. So simplify, my goal here, my idea is I'm going to keep simplifying until I just have like a very, as simple as possible of an expression. And then I can print that expression out and solve it. I've never done this as a symbolic, this is cool. This will be cool. So simplify, for a var. We'll see. I've never done it before. My goal here is actually to get all the way down to the bottom, and I'm going to solve it by hand. But then I might implement the evaluator because this looks fun. If I have time. So I'm going to be streaming for about another hour 15, hour 30, and then so we'll see how far we get. But let's write a simplify here. So when we simplify a var, we basically are going to say, if we can simplify it, do it. So we're going to say, if lookup dot get try get val of key. So if we're able to look this up, yeah, if we're able to look it up here. G says nothing hard here. That's what I felt. That's how I felt yesterday. So that's always a good sign. So if the expression exists in here, so the idea is my human expression is I'm gonna leave it out. I'm gonna leave it out, and so then it's just gonna leave an expression in my statement. Yes, G, that's exactly right. So what I'm gonna try to do is I'm gonna simplify my expression by evaluating everything, and then I'm gonna have human left in there, and then I should be able to just do some algebra to solve it, hopefully. So basically get it on the left side, and then if for fun I might go ahead and build a fixed point iterator, which will solve a linear equation. And it shouldn't be too bad because human will be the only variable in there, so you should be able to, unless there's like, we're gonna have division, multiplication, addition, subtraction. You should be able to simplify it so you have one on the left side, and then get the expression on the right side. So it becomes I don't even know if it's a linear equation. It might be a linear equation with 2 variables. Yeah, with 2 variables because you have the left side and the right side need to be equal. So we're gonna eval the left side, eval the right side, and then we'll check for equality. Val, expression right side is expr, and so then we're gonna simplify the left. So expr simple equals expr.simplify lookup. So we're going to simplify it, and then we need to do a match on it, right? So then we're going to say, well, if it happens to be a val, then yeah, so if it's just a val, yeah. I think. All right, I'm gonna let my brain's gonna get confused now. So, but we're gonna return here simple switch. So the idea is if I am a val, I should just be able to return simple, right? All right, we'll see if this works. I might have to come back to this in a second. So if I can look it up, it's there. If it's not there, I stay as a, yeah. So if I can't simplify, if my key's not in there, I just return a myself. Override. Yeah. It's telling me that this can be null. I think I can safely ignore that. And expr. I always get a little bit annoyed by this. Converting nullable or possible null. That's what it wants. That's what it wants. Okay. So my simplifier for a val is just to return myself. That one's pretty straightforward. Public override expr simplify dictionary string expr lookup. This just goes to myself. The bin op is where things get interesting, because if you can simplify to a val, then you need to produce a new val at the end. So we'll do something similar. Simplify. It's gonna be a new expression. So we're gonna say expression left is left dot simplify lookup. Expression right is right dot simplify lookup. So we simplify each side. Then what? Then we need to say we have a case. Yeah. So return left, right, off. Switch. Okay. If they both happen to be var type, so we'll do var L var R goes to, oh, so val. Sorry, this should be val. So we have val. It becomes a val L dot value L and then we can eval. Yeah. And then we do new new bin op L R op dot eval lookup. What is it? Complaint about matching the tuple expression left. Oh, requires 3. I don't need this anymore. Okay, so if we happen to be two vowels, I can do a bin op on them, evaluate them. Otherwise, my expression needs to sort of be propagated down. I have my expression left over. So in that case, I should end up with otherwise, I return a new bin op of left, right, and op. Yeah. So to simplify a bin op, if we get down to we have two values, we do that. Otherwise, we end up with the simplified left expression, the simplified right expression, and the operator we want to apply. Okay. And so now when we parse in, all right, so here's how I'm going to do this, I think. Void part 1 is this. And part 2 is pretty similar. We're going to parse it in. We need to get rid of, remove hummin. Is that what it was? Hummin or hummin? All right, so we remove the hummin key. Then we simplify. Expression. How would you do expressions like x plus 3? How would I simplify that? You're asking how I would simplify that? Or how I would solve for x? Oh no. Simplify. Oh boy. Something isn't right here, I think. Or our expression is. So solve for x. So you'd do the algebra there. I'm not with my code. So here, if I have the expression x plus 3 divided by 17 minus 5 equals 2. This is the expression. We have x plus 3. We simplify this. What's that? 12 equals 2. Multiply by 12. 24. Subtract 3. So we could solve it algebraically like that. But you're gonna have a linear equation where ideally you're gonna have it on both sides, right? So you end up with an equation where you have x on both sides. So I don't know how I would do that like programmatically. I've never done that. So yeah, I don't. What's interesting here is I actually don't want to solve root. I want to look at, all right, let's find root. I want to simplify these two expressions, my left tree and my right tree, and then set them equal to each other. So I actually care about, I'm cheating a little bit here. Yeah. So I'm going to cheat a little bit here and pull these out, and then I will, just to make see if what I'm planning to do makes any sense. PPPW. This would be left. This would be right. Right. Kinda need to write a pretty printer for this. Okay, so this one's interesting. The right side just happens to be 150, so that makes it easy. And my left side's just hard to read. So I think I need to I think I need to write a pretty printer here for my expression. Just for my brain to be able to do it. Yeah, so public override string to string. This is just gonna return key. This one's just gonna return val. Oh, you're Gson. I think I have. You're probably right. You're probably right. My brain isn't quite there yet. You're ahead of me. You're ahead of me, G, for sure. And then this one, we'll just make sure we add in lots of parentheses. Around our expressions. And we'll do parenthesis left up right parenthesis. And I think this will give us something that's a little bit easier to look at. So many. Yeah, so we're gonna end up with an expression like this. Okay, what does that look like for our... I'm gonna cheat. I'm gonna cheat here. Oh, I guess I shouldn't cheat. I guess I shouldn't cheat. So what I'm gonna do is I'm gonna look up my value. My root string, I want to save it so that I know what the expression on. Oh, well, it should be simple. It should be simple. My root. All right, so we're gonna say expression or root equals vars of root. So we're gonna pull out our root. We don't want to simplify just yet. We want to get the left and right side, and so I know for sure root is going to be a binop. So I can say binop here. And my left expression, so string left var is equal to, well, I guess I don't even need to do that. I can say left is equal to root dot left dot. So I know it. I know that it's. I know it's gonna be a var. String left key is root dot left, and I know that this is gonna be a var dot key. Do the same thing for my right. And then I can do left. Oh, not left. Left key, right key. And I'll say that left key colon is left, and right key colon is right. Oh, and then I gotta switch to input. All right, this is hopefully not gonna be horrible. Okay. So then I just need to solve for humming. Just a little bit harder. So you could, all right, so I could write a mathematical thing that has a bunch of axioms that say, okay, here is the transitive property, here is this property. I could do that, or I can do this. Oh no, Wolfram Alpha, save me. Alright, if I put this in here, will it simplify it for me? Oh no! It will not solve it for me. Okay. All right. Well, I suppose I could do it by hand here. The parentheses are gonna hurt my brain a little bit. Or I can write a simplifier. That's a thought. I could also. Wolfram Alpha says my input's too long. You've exceeded the maximum number of characters. So I'm a little. I think that's really funny. Got it. Okay. So yeah, I have. So what I can do is I can apply certain rules here that say, okay, if I really want it, or I could do a symbolic evaluator. All right, symbolic evaluator. Is there one online? I just want to pass it in. I don't want to write it. I don't actually want to write a symbolic evaluator. What's nice is it's only on one side, so I could. All right, here's the cheeky. I'm assuming it has to be an integer. Yeah, I'm assuming it has to be an integer, so I could be a little cheeky here and take this expression and see if I can iterate over possible inputs for humming until I find this value. So the question is, like, how big is humming gonna be? and how fast can it perform this evaluation. I'm going to start that up. And then consider building an evaluator. So I know my right side happens to be done. All right, so I can actually do int right is equal to right.eval. I can do that. Right val. Right. Yeah, that's probably what I should do. This expression scares me. I thought I'd solve it by hand, but it's a little bit more nested than I thought it would be. Eval with lookup. Only 5 lines. It looks like Lisp. Oh, this should be bars. Okay. This needs to be a long. So I'm gonna do something dumb just for now. For long, hummin equals 0. Hummin less than long dot max value. Hummin plus plus. There's obviously going to be a better way, but I can like look at if I'm getting closer, right? So I should be able to print things out and see am I getting better or worse? And I don't know what exactly that means. But this is my dumb solution. Well, ideally it's gonna find it before it gets to the end. I'm hoping it's small enough. This is my dumb idea. This is my dumb idea, so I don't have to write a simplifier. We have an hour. That's right. So I'm gonna start this up, see if it will find it before I can come up with a better solution. That's the idea. Right val. So we're gonna create a new dictionary from string to expression. Lookup. And we're gonna give it the key hummin. And this is gonna be equal to hummin. New val hummin. Right, and then we're gonna do left dot eval with our lookup result, and then if result is equal to right val, console dot right line hummin was result hummin was hummin, else console dot right line. I'm hoping I can glean something here. Right. Result not equal to right val. All right. So we can see it getting closer, right? So it's going down. I'm going to end up with a divide by 0 at some point. Um, oh no. This isn't even close. We're gonna play a dumb game here. Jeez. Is this doing anything? Okay, so I think I could do like some kind of binary search here, right? Where I'm gonna be smart about how I increase or decrease Humming to get there. Because basically, if I'm... Yeah, so I think I can do a sort of binary search here rather than increasing Humming like this. To get closer. So I'll do fewer iterations on it. Okay. So I think I can do a binary search. Let me figure out how to do that. So Humming doesn't get Humming. We'll just do a wild true here. And we're gonna start Humming equals 0. God, my brain's gonna have to figure out how to do binary search at 6 in the morning in this mathematical way. Okay, so otherwise, and I need to make sure Humming doesn't get set equal to like 960. I saw real quick. Let's just comment this out so I can get my values. I want to make sure 960. Oh no, that'd be okay. I just don't want like a divide by 0 error to happen. If it happened to be 0, that would be okay. I just don't want to divide by 0 error. Well, we might just wrap it in a try if we run into a divide by 0. All right, so we're gonna do binary search to find it. So we're gonna say, what did we? If result is greater than right val, we are going to go halfway between it and our maximum. So int half is equal to Humming. So it's going to be our current max. So int, so long max is long dot max value. Max just max divided by 2? No, max minus Humming. Divide by 2, and we need to increase by that amount. And then we'll do Humming plus equals half. All right, so else we need to go the other direction. And this should break. All right, so this, oh, and my new max, my max doesn't change. Okay, so my max changes in this case though. Right? I have a min. Humming is my min. Hummin is min. All right. So go halfway up. Why is this so hard in my brain? I might need to draw this to see it. So we keep increasing. Otherwise, we decrease by half. Max minus Hummin. And then our new max equals Hummin. Yeah, I should probably just do it by hand, but there's so many numbers here. I don't want to do it by hand. Oh no. Gee, thank you for pointing that. Oh, the binary search. Yeah, I should probably write it out. My brain is melting, but it's more fun to watch me sweat, isn't it? So if, all right, let I'm gonna do a little thing here. Console.writeLine, wrong way. Break. Topologists, thank you. I appreciate that. I really do. I'm glad you enjoyed them. My goal, I try. So I am a teacher, so I do want to make educational videos for my students. All right, my halfway is wrong here. But thanks for popping. I'm so glad that you're here. Always nice to have someone around. All right, we're gonna do long min equals. My brain can't handle this Hummin being min. And I think there's something broken with Hummin with it being min. Yeah, I try to be educational. Gee, my YouTube channel is more educational, perhaps. This is mostly me just, so one of the things I like to do is be able to live stream my students, so I can say, hey, look, there's the process. There's a process behind problem solving. There's a process behind programming. You're not always, and in fact, you're very rarely, especially early on, going to know exactly what to do right from the get-go, right? So it's about exploring that space, and that's what we do. So max, our new max comes down to Hummin. Our min doesn't change, and our min becomes Hummin here. Is this more correct? No. Not even close. And it's like stuck here. So rather than I'm not sure if this is even the correct approach. Too low. Console.writeLine too high. Yeah, topologist, great question. My plan, topologist. Give me just get sal. Am I saying get sal? Is it get salad? Am I saying that right? Get salad. Give me just a second here, and then I might ask for a little bit of help. But to topologist. Sorry, I'm trying to answer you. My yes. I was teaching. My students have gone on break, and topologists, thank you for the follow. My students have gone on break, so I was highly motivated to make the videos because I knew my students needed them and were using them. but now everyone's on break, so it's a little bit. They're starting to take me a long time to get done. My plan as of right now is to make a video for every day, but the harder ones, yeah, we've discussed day 16 a little bit on this channel, maybe even at length. My goal is to make all the ones that I think can be done simply. I'm gonna make a one-off video for that. Some of the days, day 16, I think, day 16, day 19, some of the ones that involve more difficult concepts, I'm gonna turn into like a little multi-part video, because there's things, there's no straightforward answer, straightforward, simple brute force solution. You gotta know a couple concepts. So that's my goal. We'll see if I get there. So I'm gonna try not to make any promises, but that's what I want to do. Let me say that's what I want to do. I made a little read line here so I can see what I'm doing wrong. Console.writeLine. Min max. Yeah, so I need to do a video on graphs. That's essentially what I need to do. So I need to do a video on graphs. I need to do a video on searching graphs. I need to do a video on like all pairs, you know, shortest, you know, all pairs shortest path. Yeah, day 16 and 19, it's about coming up with a good strategy. And let me put out what humming is. Ah, here we go. Humming, I'm starting wrong. Should be max minus min divided by 2. Okay, I had something here. My binary search is not updated right. All right, so too low. So low should become this number. And it didn't. All right, so my min is not updating. My max, all right, so I'm doing too low. My min becomes humming. All right. See, you were right. Doesn't have, it has something called a decimal type, which is pretty close to arbitrary size, but it does have a limit. It's not arbitrary. But it can get quite large. It's is that right? Someone correct me if I'm wrong. Is decimal? No, I don't. Decimal is like big decimal. I'm not 100% sure now, actually. Min equals humming. Humming should go halfway between. Yeah, see, I was doing something weird here. Max, I was too high, so my max becomes humming. Humming goes halfway between. All right, someone let me know. All right, it seems to get stuck somewhere. I'm not doing, what am I doing wrong here? Too low. Oh, this needs to be min plus. All right, min plus Okay, so there is a big integer type. Okay. All right. You would think I would be able to get my binary search quicker. I'm not able to do it. Oh, why can't I do this? Something's gone terribly wrong. Why? All right. Am I just... Is binary search not an actual solution here? Yeah, am I just doing binary search wrong? Or am I going up too high to start with? That would be sad if I had some overflows. You could be right. Here, let's oh, with my number being so giant, you're right, I am having overflows. Yeah, it's slow because I added a little check here to make sure my binary search was proper. You're right that I have overflows. You're absolutely right. That is definitely what's happening. So, yeah, thank you. I was like wondering what was going on here. So, it's sort of, I just need to start sufficiently high. I need to start with a sufficiently high value. So rather than max, so this is what it was. So I want to start with something sufficiently high that won't go over. All right. Let us try this number. Also not okay. Oh man. Oh man. So my negative number could be from my initial expression. All right, so I have this. I might just give in and do it by hand. So here is the expression. Here. All right, so it has this expression. So if I multiply by a negative number somewhere in here, it would become negative. Yeah. The expression can result in a negative number. Let's C# big integer. Let's see if there is. Oh, this. I had done. All right. What if I think I think it's overflowing. I think you're right that I am. Oh, my HUMN is not overflowing, but my result that's coming out is overflowing, which is messing up whether I should go up or down. So the result that I get tells me whether I should go up or down. And the reason I had done this, so I'm gonna do something dumb here. Enter Hummin. All right, so I'm gonna do something dumb here. Int.parse console.readline. All right, I'm gonna let myself type in a value for Hummin just to make sure I'm not crazy. All right, because I started with 0, right? And then I went, okay, well, let me put in like 10 million. Oh, I need to press enter there. All right, hang on. I'm being dumb here, so just let me sweat a little bit more. Here's my expression. I'm gonna sweat a little bit more. If I put in, is it able to parse this? It's not. Okay, that's too bad. Let's go with 1 million. And I'm not even close. So then I went to 100 million. Yes, also not close. Overflow. Oh, I want to do long dot parse. Because I had by hand done this and saw that, oh, it's just going to get closer and closer and closer. 5, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. No, that was an overflow from parsing the number in. Yeah. So let's try 5, 5. I wish I could press the up key to do get my last value there. Too low. Yeah, so I should be able to do binary search. I'm just not starting at a, you know. All right, so I can sort of say that. Here we go. I can start my min here at. Did I break something? What's going on? My keyboard's not letting me type anything in my console. All right, let's kill that. Let's try again. All right. I found like I'm gonna find a reasonable min and max for my problem here. All right, so it was like 5, 1, 2, 3, 1, 2, 3, 1, 2, 3. Too low. All right, so if I were to start my min here. All right, and then this. Oh, I'm also something's. too low. Yeah, I think you're right. I think you're right. That should be max. I think, or I haven't been doing this right. So too low is saying that my result was too low, and I should increase my number. But increasing my number goes the wrong way. Too high. Let's see if this does anything. It... I'm doing something so wrong here and it's making me crazy. It's making me crazy. Let me put these on 2 lines so that I can see them right next to each other. All right, so I'm getting stuck here. My binary search is just clearly wrong. Clearly wrong. And then I also want to, all right, so I'm gonna do the manual binary search. I'm gonna do manual binary search. Oh, you think I have this? Oh, try and flip the conditions? That's a decent, all right. I think, well, I mean, I'm just having trouble, yeah. Get salad. Oh! Oh, topologists! Thank you so much. Topologists. Yeah! Let's, go see. Ho-ho! I had my bite. So, get Sal there. You were trying to give me that hint the whole time. I should have given in. I should have given in. You're giving me the hint the whole time. I should have done that. You were right though. I should have done it by hand. Yeah, many minutes ago, 20 or so, 20, 30 minutes ago, I think you had said, "Oh, I do this thing by hand because it would melt my brain." And sure enough, there I was. All right. Very happy to have finished that one. Let me add in. That was fun. That was really fun. I would love to build a symbolic evaluator. That would be really cool. That'd be really cool. Be hard, I think, because you have to program like rules to do it, I think. I don't know exactly how to approach it. I've never done it. Let's add this in here to our git commit -m feat implement day 21 parts 1 and 2. That was fun. That was such a fun puzzle. Ooh, I could do it recursively. Oh, gee, you're a genius. Oh my goodness. Oh. Oh. G, you're a genius. So G is saying, all right. I love this. Void Part 3. This is a genius. In Python, you get basically for free for test 2. I set the Humming magic around. It would simplify everything for you. Yeah. Oh, this is genius. G says, get your vars. And then we know that there's no recursion in it. We know in my specific instance, I'm imagining this everywhere. In my specific instance, we can do vars at Humming on eval vars because it only appears once. So long result. Does this actually work? Oh man, that's a good one. That's a great solution. Is this what you're suggesting? .NET run project solution. Oh, hang on. I need to oh, hang on. I don't quite understand. Let's go look at what Humming says. Humming's just a number here. Okay, so I'm not quite. I didn't quite think that through. The function is pretty tricky whenever I look. So I have a function called must be variable comma value, which says what each variable should have been. Gee, I would love to see your solution there. I thought I understood what you were saying, but I don't think I do. You could also just find out Humming number by doing it recursively like you did with the X equation. Yeah, I don't understand how I could do that. Oh, so like I go in recursively and work my way out? Oh, I think I understand. Never mind. This is dumb. This one doesn't do. Ignore my madness here. Don't worry about it, G. I was just really curious. I'm just happy that today's puzzle was a lot less stressful than yesterday's puzzle. Yesterday I was so incredibly frustrated that I almost flipped a table. I was ready to be done. Right, so I want to figure out let me move this to the end just so we can see these expressions again, right? Yeah, so I'm also thinking the same thing. Get salad. I was pronouncing it right. Now I think I'm pronouncing it wrong. Here. This was fun. Okay. If I could go salad, get salad. Yeah, so I need to find a way to extract Humming to be on the left side of the expression, right? So my symbolic evaluator, I could put in some axioms here that say, okay, when I multiply, I can simplify this to Humming times 7 minus 960 times 7. Interesting. I actually had a student, right? And then I can keep,
recursively simplifying this thing. Let's see if I can. Let's see here. I'm gonna get coffee real quick, and then I'm gonna come and explore it. Yeah, something like that. I need to get coffee. I will be right back, and then we will keep exploring. I got another 20 minutes, so I'm gonna get coffee. Then we'll spend a little bit of time talking about it. I'll be right back. All right. We are back here. We've got a little refresh on our coffee. All the intermediate values. I guess I kind of don't understand. Gee, I feel like I kind of understand what you're going for, but I don't know how I would implement it. So we know that if I started with root, equals these, so RPG was this, so I started with GG must be this. And then do you say, so you have GG, JG. So you look at this and you know, so you end up with 1/2 being solved, I think you're saying. You're saying, well, then those must be equal. I don't quite understand. So I apologize for not understanding. It's not entirely clear to me. Yeah, so you pull it over to the other side. Exactly. And then if you happen to have an expression, you go through and do that. All right, I'm gonna see if I can write what you're suggesting. Yeah, I know by hand. I understand it by hand. I'm not quite sure I know how to. I think you're saying transform. You transform the. All right, we're gonna try. We're gonna try and write the function you're describing here. I was gonna do a little thing where I was gonna try and eliminate multiplication by like applying transitive and associative properties. I think I like your thing here. I like this idea though. So we're gonna have public, static, your method, and so the idea is, what does this method return? Must be. So if I look at this program here, I know that CGDH must be this number. Gotcha. And so you look up the original CGDH. Gotcha. And okay, because Humming only appears once, we can actually come in here and say, well, evaluate both of these values. I think I understand here what you're doing. So let's try that. Public static void must be. All right. Expression E, and then the right side is actually going to be a long val. And so we're going to set, well, we'll print out. We know that the expression on the left, or actually this is going to be a string var, so it's going to be the variable name. Okay, and I'm also going to take in my dictionary. Oh, so that otherwise I'm going to be evaluating over and over and over. Gotcha. So I need like a quick lookup. So I do something like this. So I do a quick lookup. So I'm gonna assume. Here's what I'm gonna do. I'm gonna write a memoization. Public. Static dictionary. String long. Pre-compute. I'm just gonna do this real quick. Look up. We'll call this one memo long, so I don't have to do it too much here. You're probably right that I shouldn't have to do it. So we're gonna say here, console dot write line var should be val. And then I know that if I have a binary operator, I can move it to the other side, right? And so then I can say express binop. Yeah, so I know it's going to be a binop as I'll call this expression equals lookup var, right? And maybe I shouldn't do this here. But I know it's gonna be a binop, and if it's not, so I'll do if. Because I only want to do this if it happens to be a binop. Exactly. This is cool. I really think this is a neat solution. We're gonna see if we can get it in 10 minutes. I might go a little bit over time. I have a phone call I gotta make shortly after I get off, though. I don't have work today, but another teacher, my best friend actually is a computer science teacher. We're doing a collaboration next term, so we're gonna meet this morning to talk about it. If expression is, yeah, get salad. I am a computer science teacher. Teach computer science and programming, and a little bit of random stuff too. So I have a couple part-time teaching jobs actually, but my main job is teaching online middle school. So I work for a school that is completely remote, and I teach comp sci to ages essentially 7 to 17. But my main job is teaching computer science in a remote middle school. Yeah, it's awesome. So the videos I've been making for this are designed. So if you ever check out my YouTube channel, the videos I've made were designed so that my middle school students could solve them. So a lot of them have been programming for, like, it's crazy. I have some like 16, 17-year-olds who essentially have almost an entire undergraduate program. Yeah. How do I check if expression is an instance? If expression is binop, then I want to say binop. If it's not a binop, I kind of want to stop. Throw new only works with binops. Yeah. So I'm like, it only works with binops for now. So we're gonna do a thing here where we know we're only gonna recurse on binops, I think, and then we end up with a left and right side here. So I have binop. This is a cool solution. This is exciting here. I'm really excited about this. possible solution. Binop equals binop. I'm going to convert it to a binary operator, and then I can sort of match on it. So var should be, and then I'm going to do a console.writeLine. This becomes the binop equals val, and then I'm going to take the left side and move it over to the right side. So then we're going to do switch binop dot op switch and it doesn't like var x equals. Yeah, that's fine. That's fine. Plus goes to we have like the left side and the right side, right? And we know that they should be variables. Yeah, this is beautiful. This is beautiful. So then we're gonna do binop. So this becomes sort of like must be. All right, so this is gonna become an action that takes in a string long dictionary. Oh God, this is definitely want to just be a var. So this is gonna become like a partially applied. I want to recursively call must be with the expression on my left. Okay, all right, so string left key is equal to binop dot left, and I'm gonna force this here to be a var. We know this is true because all binops have vars on the left side. Dot key. And then string right key equals similar thing. And char inverse equals binop.op switch. And so I should do that's a fair point. That's a fair point. You're right. You're right. So I go, okay. So to do that, I'm gonna do binop.left.simplify. All right, expression left. And I basically say, is this a val? My program, I can kind of do it this way. So this is going to be a val on the left or right side. So I'm not actually using my memoization well. So maybe I should go ahead and do that. We'll be a little bit lazy here. I think I have conceptually what's going on. My left key, my right key. Yeah. And so if left is val, right? So if I have a val on my left, I need to move that to the right side, right? Else, my right side isn't evaluated properly. So yeah, this is cool. This is cool. I really, really like this. Gee, thank you so much for mentioning this solution. I think this is an awesome solution here. I do have to stop. Here. Thank you. Thank you for that. Yeah, this is fun. This puzzle was really, really fun. I'm glad it existed. Yesterday made me sad. It was hard. But everyone, thank you so much for tuning in. Thanks so much for watching. As always, I hope you guys will continue coding, continue coming to help me program. This is awesome time here. And you're welcome back anytime, of course, if you ever want to come on back. But thanks for hanging out. Have a beautiful day.